Recently, I dramatically improved the time to first byte on my website. It went from around 3.5 seconds down to under 700 milliseconds. And I did this with just 2 small changes. Here's how I did it and some of the architectural decisions I had to make along the way. But first, let's talk about performance. As developers, when do we actually think about performance? I typically think about performance when I'm building a new feature and I want to make sure it's good, or when I've suddenly discovered that performance is really, really bad. And that's what happened to me when I finally added Sentry to my personal website. Now, my personal website is a static site. Traditionally, a static site is pretty performant out of the box. It's pretty fast. It's delivering static HTML to the browser. My personal website has always been my playground, a place to experiment with new, exciting, cutting-edge, bleeding-edge technology. And I went too far, and my time to first byte was terrible, and users were having a terrible time. Some users experienced a time to first byte of 10 seconds or more, depending on where they were in the world and what device they were on. I was embarrassed. And I was mainly embarrassed because in 2022, I completely refactored my personal website in order to prioritize performance. I went from using Next.js to using Eleventy, producing a completely static site, a folder full of HTML files, and I was really proud of it. But as time went on, I added more and more features, more and more functionality, and layered on top of each other, they caused a problem. So let's have a look at what was happening. When middleware and edge functions first came onto the scene, I was really excited by them. I could serve a static file. The middleware would intercept the request, make a few edits, and send it back to the browser. But it turns out that layering edge functions or middleware on top of edge functions and or middleware can actually be very bad. Here's how my homepage worked. A user would make a request to my homepage. At that point, a newsletter middleware function would intercept the request, call out to a third-party API to get the number of subscribers that I have on my newsletter, modify the HTML, and return it. At which point, another middleware function would intercept the request again and make a call to the Twitch API to see if I was live on Twitch. If I wasn't live on Twitch, it would make another call to the Twitch API to get my latest stream data, grab the thumbnail and the title, and rewrite the HTML of the page before it sent it back to the browser. Now, these middleware requests were happening on the edge at the closest server location to where the user made the request, but the APIs were not running at the edge. They were running in fixed regions, and that doesn't really make sense. Even though you're requesting the data from the edge, which should in theory make the whole thing quicker, if you're calling an API that's not on the edge and in a fixed region, which currently most APIs generally are, it's not really going to improve the latency. So this resulted in a P75 value of around 3.46 seconds for the time to first byte of my homepage. Now, the P75 value is the highest value that 75% of my users experienced. And this meant that 25% of my users were experiencing a time to first byte that was even higher, sometimes up to 10 seconds. And before I tell you how I fixed it, let's first discuss why I thought this was a good idea. I need to make a confession. This was a terrible way to build my homepage. And it's to do with data and how people use my homepage. Who really cares about the number of newsletter subscribers I have other than myself? And I actually used to refresh my homepage just to get the updated number of newsletter subscribers rather than go into my newsletter platform dashboard. Completely unnecessary. Secondly, the call to Twitch when I was live got the most updated thumbnail that was refreshed every 5 minutes. And what purpose did this serve? The Twitch thumbnail that updated every 5 minutes was usually pretty rubbish. It didn't really tell you anything about what I was doing. My face probably looked a little bit weird. It didn't give you any real context. Why would it encourage you to click into the stream to watch it when I was live? And no one's sitting there in front of my website homepage when I am live on Twitch refreshing every 5 minutes to get the updated thumbnail. It was actually a pretty useless feature. First of all, I made the number of newsletter subscribers static. It was generated at build time, called out to the API at build time, and put the number on the page. Now, to account for slight inaccuracies in data, I can put a little plus symbol next to the subscriber number to indicate that maybe I'll have more. And if at build time the API call fails, I can just replace it with a string. It's easy, it's simple, it's uncomplicated, and sometimes those are the best solutions. Now, in removing that first middleware call to the newsletter API, I reduced the P75 time to first byte from 3.46 seconds to 1.88 seconds. So that was an extra 2 seconds that the newsletter API call was adding on to that request. So now let's talk about what I did with the Twitch data. My initial hypothesis was that if I moved the call to the Twitch API from the server to the client, I would save another couple of seconds on the time to first byte, but the user experience might not be as good. You'd have to wait a few seconds, potentially, for the Twitch data to load in. This might in turn cause more cumulative layout shift as the JavaScript fetched the data and put the thumbnail and the title on the page. So I made a better decision. I chose to build the Twitch data statically into the home page as well. So now when I go online and offline, I send a webhook to rebuild my site every time. When I'm offline, my homepage is built statically with my latest stream information, the thumbnail and the title and the link to the video. When I'm online, here's where I had to make a compromise. So the whole point of my homepage is to send people to my Twitch stream. I want people to know when I'm live so that if they land on my page and I am live, they can come and watch me and see what it's all about. When I'm online, I chose to use more client-side JavaScript to load the Twitch video player. Now you might think, Salma, why are you loading more client-side JavaScript? You don't want to do that. But I made that decision based on me being live for around 6 hours a week. That means when I'm offline, for the rest of the week, you get a completely static performant experience. So now each time my site is rebuilt, it calls out to the Twitch API to check if I'm live. If I am live, there's a bit of code to load the Twitch video player. If I'm not live, it gets all the data it needs to build the latest stream information on my homepage with a link to where to watch the video. So all this to say is that performance is a balancing act. My newsletter subscriber number was not important. My latest refreshed every 5 minutes Twitch thumbnail was also not important. But what is important is that when users land on my website, they see something as soon as possible. The time to first byte is as low as possible. And these two small architectural changes yielded an 80% improvement in the time to first byte on my website for 75% of users. It's been reduced from around 3.5 seconds to under 700 milliseconds. I do have some more improvements to make, but an 80% reduction I think is a really great start. So in conclusion, performance is actually about how you build your site as well as what you build your site with. Performance is the architectural decisions you make along the way, and performance is also the things you choose not to show on your website. Performance is whether or not data needs to be completely up to date and accurate or not. And as my good friend Cassidy Williams says in this article, your websites start fast until you add too much to make them slow.